All right, I have started recording this, so in case for those of you who are not able to hear or follow, you can hear back later. Okay, that's good. So it looks like most of the students can hear me. Okay. Again, good evening, everyone. This is a course overview or introduction about Data 630. And I have, by the way, I have the chat window open in case there's some issue I'm following, so you can type in something. So there are two sections for this semester. Typically, every semester we have at least two, sometimes three. And I'll be teaching the section 9040 and 9041 is taught by Dr. Amy Gates. And then we have a TA for both sections in the data. So like I said, this is a course overview. We will go through the structure of the course. And yeah, so this is the agenda that we will be covering tonight. Introduction, some of the expectation, what sources are available for you to succeed in the course, and the expectation, and the content, and the potentially time management. Unlike the previous course, you'll find that there is heavy material because this is where we cover the fundamental concept of machine learning and data mining. So there is quite a bit of work. And grading, which is important, and we'll cover about the grading guidelines, some miscellaneous part, and then we'll have some time for the Q&A. So as you are probably aware by now, I think since a few years ago, the university requires no textbooks. That means we don't have to purchase any particular book for the course. Having said that, it is we follow closely the books that is recommended in the book by the Introduction to Statistical Learning, and there are two books in that. And although we will not cover heavily mathematical aspect of the course, but eventually at some point you will have to deal with that part as well. So there is two books authored by the same folks. One is, like I said, Introduction to Statistical Learning, the less mathematical one, and there is another, Elements of Statistical Learning. But again, you're not required to purchase the books. And at some point, and then both are available free online, and I believe the links are provided on the website. So, and as you can imagine, there are many web-based sources, articles, and things like that. And for each module, we also have lecture videos provided by the professors. And once in a while, when there are seminars sponsored by the university, I will provide links to that and post the information. So all the available information will be provided on the website for free. And that so the last bullet says check the news section often daily would be ideal. It's unlikely that I'll post anything new daily, but minimum weekly. So the module runs, most of the modules have 2 weeks, but less every week, likely 1 or 2 announcements. Anything new, any coordination done by the university, so things like that will be posted on the website. Okay, questions. I will not be answering specific things, so you have to hold Dennis. Any question, I will, when I get to the Q&A session, I will address any questions about the course and requirements. So the course placement, in my understanding, is by the time you are taking this course, you have already at least covered 2 of the courses, which is data 610 and 620. So there is a reasonable expectation that we have covered some of the basics about data science and a little bit of programming as well. And this is the relative placement of the data 630. So in data, this is loosely mapping, obviously. So 610 and 620, we have discussed about descriptive and diagnostic, why things happen, what happened kind of questions. We will continue to explore those in data 630, but in data 630, you will apply more machine learning type of algorithm to help answer questions like that. And then you get into the predictive role where you train, generally two classes of predictive models. And we will focus a lot on the supervised learning. That's where you have training data, you fit a model or you train a model, and that model becomes your predictive tool and will be able to predict things that are unseen before or future observations. So that means we will cover most of the algorithms that we learn in data 630 around predictive. And in data 640, some of the things we cover in this course will be covered in advanced manner. For instance, we will cover decision tree in 630. When you get to 640, you will learn how to ensemble, apply multiple trees in ensemble. That means how you combine multiple trees to be able to fit more powerful models. Also, we cover neural networks, but when you get to 640, the advanced application of that, which is the deep learning. So things like that. So 630 and 640 go hand in hand, but we will cover the fundamental concept in 630, and then you apply the advanced application of those techniques in 640. And obviously, you get to the high level, you get into prescriptive. I don't know to what extent prescriptive application in general harder. It's not prescriptive is not only predicting, but how will you be able to recommend a course of action to change events from happening. If there is something that you want to prevent, you don't only stop predicting, but you recommend a set of actions that could be taken to change the course of events. So that's a relative placement of the course. It's a very, very important course at 630 for the program in general, because people at the data science are expected to fit models, and then this is how it's a modeling class. And like I said, focus on techniques, hands-on programming exercise and assignments. We have a lot of assignments, exercise, a lot of them, from module to module, and all of them done in R. So R is the programming language that we use. And I know from semester to semester, I get diverse backgrounds. Some people have done some work in R, some are new to R. Some of you, at least from 620, have done a little bit of Python. And I would imagine that you can extend, apply some of the skills that you have from Python to R, but there is substantive differences as well. These are the topics. Before I talk about the topics that are covered, let me talk about the structure of the course. So we have modules. Each module, except the second module, have 2 weeks. For instance, in module 1, we will cover one topic in first week, and the next topic in the second week, another topic-related topic. But for the most part, in modules, the topics covered are identical. For instance, when you get to regression, all 2 weeks you will be learning about regression. And so the workload is a little different from first week to the second week. So that is the structure. Now, there is only one module with 1 week, which is the next one, the association rules one. So that week tends to be a little heavy for most students, because we cover both the exercise and science assignment in yeah, in that module. But all the others are 2 weeks modules. And the last module, which is module 7, is 1 week, but that is for you to finalize the project work, the class project. So the first module will cover data preparation and visualization. This is kind of introduction about the course. We will cover, some of the how you can do some basic functionalities in R. And then we move to an association rules analysis, which is a type of unsupervised learning. And we will cover about what supervised, what unsupervised means as we progress in the course. And then we move to we start our supervised learning in module 3 by covering linear regression, logistic regression, and Bayesian classification. Again, we will have 2 weeks for that, and then we'll move on to decision trees and neural networks. We cover decision tree in module 4. In module 5, we'll learn about neural networks. And then finally, we move to one type of unsupervised, another type of unsupervised classification called cluster analysis. And like I said earlier, there was a lot of material because this is a fundamental course. We will cover a lot of material. And in week 4, we will form groups. And you start working on group projects. So that group project will be on text mining, web, or social mining. What that means is we will not have a dedicated module to cover web mining. I hear a background noise. I gotta, sorry, I gotta check whose mic is not muted. Okay, that is John. Okay, John, I have to mute you. Okay, sorry about that. Okay, so the advanced topics will be, you will be working on project work on text mining, but we don't have, we will provide the resources in the class, and probably have seen it, one of the modules has content about text work and social mining. Okay. Moving on to course competency. This is the kind of expectation that we have for the course of competency based. Really, roughly what it means is, so you have to show your work for me to know that you understood. You might have understood the content, you might have understood the concept, but unless you show me how you do it, kind of hard for me to gauge your level of understanding. So you have to, through the work of your exercises and assignments, you have to demonstrate your understanding. We do have assignments for each main topic, and you will, after 2 weeks or 3 weeks, you will, get the rhythm of the course. And like I said, this is not to scare you, but kind of heavy, because every single week you do submit something. There is exercise in the first week of the module, and there is assignment in the second week of the module. And I'll have a slide to discuss the details of those. And weeks between assignments, which are activities, which are information experience to accomplishing the grade assignment. So that's true. So for instance, in the first module, in these first 2 weeks, we cover the basic stuff. And throughout the course, throughout the assignments, you will be applying that. Because any project, any data sciencing effort involves cleaning data, visualization, exploration. So throughout the course, you'll be using the stuff that you covered in the first module. Similarly, things that covered in the previous module to some extent will be applied in subsequent modules. So, so in that sense, you will be reinforcing what you learned by doing more assignments. And earlier I said R would be the primary, actually exclusively what we will be using. R is a very rich platform, is a language that is very popular within the statistical community, mathematical community. And there is no shortcut really. We would provide a lot of guidance, but at the end of the day, it's up to you to be able to have a working knowledge about R. It is important. You can't avoid it. There are some packages that don't require any coding, but as a data scientist, at some point you would have to be, you will be expected to do some prototyping using coding, and R is really, really good for that. And there is, I guess, depending on your perspective, there is a learning curve for everything. But we have a discussion forum that is dedicated for this purpose. The TA is responsible for answering questions. And one thing I would have to say is spend some time before you post question about you're gonna get errors, and then that's the nature of the problem. It's not unique to R. Any programming effort will involve them. So you'll run sometimes a syntax problem, maybe a package dependency. You'll run into that issue. But spend some time researching the problem, and most often than not, you will be able to resolve yourself. But in case you can't, just post it in the TA forum for programmatic problems. And discussion and interaction, this is another, we have throughout the module, we have graded discussions on the topic covered that module. And it's important, and it's really the nature of the platform, an online platform. I guess that's the best way to interact. And so there is expectation that you will be posting initial post as well as response posted throughout the module. The second module doesn't have a graded discussion because there is only 1 week in that module, so unreasonable to expect for you to be able to work on the discussions. I believe I have said pretty much most of the R, and R Studio is an IDE. There's no requirement that you have to use R Studio, but it makes life a lot easier to work with R. It is integrated development environment, which makes some of the mundane tasks easier for you to be able to do. And the bullet point here is the R is not just a language, and it's a platform with rich libraries. And believe me, although there is a learning curve at the beginning, you will find everything related to machine learning and statistical learning in R. Any new algorithm, any new things that is tested or being researched, you will find implementation for it in R. I guess you can make the very similar argument about Python. I do have experience with Python as well, but I guess maybe I'm biased. R is a bit richer. Tutorial for each module by the TA. So in addition to the resources provided in the lecture videos by the professors, the TAs for each module also provide seminars, like online webinars, for covering just the syntax of it, knowing that some students struggle in the syntax and finding the right packages. So for instance, for this week, for this module, Introduction to R, I believe it has been posted already. So that is another thing that you want to leverage to the learning R and the relevant packages that we cover for each module. I guess I have said that, lots of resources on the web on topics on R, and I think we compiled a number of links. And I don't expect you to cover everything because you have to work on your assignments and exercises. So, strike the balance, but in case you need it, the resources are available. Okay. Assignment, and this is a distribution of the grading. So, like I said, 2 modules for except one, the second module, 2 weeks for each module. Typically, in the first week, you will work on the exercise. The exercise gives you the opportunity to get exposed to the syntax, the relevant packages, and some of the basic functionality. But when you do the assignment, it's going to be on the same topic for that module. But you are expected to provide a lot more substance. So it's open-ended question. Typically, you fit a model, you make some assumption, you justify the business case, because any data science project is not done in a vacuum. You have to have a business understanding that justifies the application. And like I said, you make assumptions, so long as you provide some clarity about the assumption you made, that is okay. And then you fit a model, you do evaluation of the model. We will cover all that throughout the course, how you do evaluation, how you do your fitting using a specific type of algorithm. Okay, but that is first. You will do the exercises first, and then the assignments. The assignments typically have a higher grade. The exercise, in fact, should not have been even graded, but this is to motivate you so that you spend some time understanding the basics before you start working on these assignments. We don't have assignments for the first module, first week and 2 weeks. That is for you to get familiar with the flow of the content, the structure of the course. So you only be doing exercises this first week and second week, like data preparation and visualization. So there is no assignment for module 1. But all subsequent modules will have assignments. Okay, so this is the distribution. Assignment 1 is 10%, 2 is 10%, assignment 3, 12, assignment 4, 12, and assignment 5, 12% of the total grade. And group project. Like I said earlier, we will form groups in in the 4th week of the course, and there are 2 milestones. You will submit the first milestone, I believe, in week 5, and another one in week 9, and then the final project at the last week of the course, and it is 20%. And I will post something in week 4, encouraging you to form your group. But if not, it's not a big deal. I will randomly assign you. But my recommendation is to pick your group based on my experience. And a total of 7 practice exercises. Okay, each week there is exercise, starting from week 1, this week right here. Each one of those exercises 2%, as are the discussion points, which takes us to this slide that talks about the discussion items. So for each module, except module 2, we do have discussions. So the discussions are 2 points, each one of them 2 points. And this is to create interactivity. Believe me, you will learn from people, and once you get the flow, you get used to what is expected. And I myself learn a lot from what students research and post. And so the expectation is they should contribute interesting observation, questions, insight, sometimes from your experience. So use your judgment what should be included in that. Okay, but there's guidelines for each discussion, the minimum length for each one of them. So the structure, so each module, like I said, 2 weeks. The first week, in a minimum, you need to post the initial post. You make initial post, and in the second week, now you can start interacting and responding to other posts the first week as well. But the minimum expectation is in the second week, you will be responding at least 2 minimum. 2 posts as a response, so a total of 3. That's minimum. People in general, post a lot more. So it adds value. I understand that it takes time, but this is the graduate course, and there is a reasonable expectation that you have to have a good understanding about the content of the course. Grading, I know this is important. But there is the graduate school policy, which says on time, on task work, well written, complete, properly documented. That is a B. Okay. An A requires additional, more relevant, more content, more substantive discussion, more argument in your assignments. Okay. So doing just the expected doesn't guarantee an A, so you have to go beyond what is the minimum expectation is. And this is some of the guidelines. They're straightforward to maximize the chance of increasing your grade. Look for ways to add depth and breadth in your answers. I really remember penalizing students just for providing more content. Don't write for the sake of just lengthy report, but more content in general. It's an easy way to guarantee a good grade. Be thorough in your discussion, kind of related point. Include alternative points. Use examples. Real examples are good. It allows me, it enables me to understand your level of understanding of the course. It allows me to see where you're struggling, where things that you're better and have good grasp. And obviously, critical thinking is important. Yeah, the last point says just content is the surest way to improve your answer. Just not volume, but look for ways to make your answer more meaningful. Okay, all straightforward. General recommendation: what do you need to do? Yeah, follow direction. Like I said, I post announcement regularly. See for those. Time management is critical. Please, that is the place where most students start early. If I haven't said it enough, the course is heavy, a lot of material. So you can imagine that you'll be busy throughout the course. If you wait to the weekend to do your assignments and exercises, then you won't be able to meet the deadline. Okay, so there is late penalty, which means you want to avoid that. Now, things happen sometimes. And I understand you're adult learners and you're busy in life, and that occasionally, but you have to send me before the due date an email saying why you won't be able to submit on time and need extension. So depending on the case, I'll be considering. But in general, start early. So which means reading the announcements if there is any new information. Post question in the Q&A discussion section for the week. If questions relevant, response needs to be seen by all and captured. So one thing I want to say on this is there are two questions and answer forms. One is for me for the professors for I guess for each section, and one for the TA. The TA is primarily for programmatic issues like error, syntax, when sometimes you don't find the package, you have a hard time installing a given package. So that kind of question goes to the QA. Content about the theory, foundation concept, things like that, about the course material. You should use the professor forum. If there are issues that are personal in nature, like grading, or you need extension for assignment submission, that should go through email. Communicate that directly through email. I check emails regularly, and it is a requirement by the university. Each professor regularly check their email, and you can expect 24-hour response. But yeah, anything private, personal, should be communicated through email. Okay, so that is in general about the course structure, content, and some of the expectation. And this slide is more, it's not unique to data 630. I just want to give you some, I guess, advice based on my experience. So data science, it's kind of a unique, exciting field, although there is a lot of hype. A lot of companies doing a lot of good work using data science. So a lot of very difficult problems are being solved using data science solutions. And machine learning plays really, really critical role in that. Underlying in machine learning is everything is statistical based, but the clever application of automation in mathematical equations are really being applied to a lot of domains. So this is a data science. What is common? What makes you a good data science is the skill sets required. Now there's a lot of variations of this graph if you Google it, but basically you have to have a mathematical understanding, computer science, and some domain expertise. Don't worry too much when you see this, and I don't expect you to be expert in all these domains in these areas. But generally, there is an expectation that as you grow in the field, you have to have a solid understanding about the underlying mathematics. Everything, when you talk about algorithms, by its nature, it's just mathematics, right? But that mathematical equation is implemented using programs. So when I say computer science, that's what it means. It is a program. I'm sorry that sorry. So the programmatic aspect is also important. Understanding of mathematics is one thing, but applying into through automation, which is a programmatic aspect, we will cover in the course, the R. But it's important beyond this course, throughout your career. Like I said earlier, although there are packages that don't require any programmatical skills, they are limited. The kind of things that you can do with those skills are limited. So you have to have a good understanding about the math. This course is not heavy on the mathematical side, because we just don't have the time to cover all the details of the number of algorithms that we cover in the course. But it's in general expected at some point you need to have a good understanding of the underlying implementation of the algorithms, and obviously the programming aspect that converted those equations into automation to be able to prototype. And another important skill is domain knowledge. So now, one of the things that I tell newcomers to the field is, to the practical, if you can choose a domain that you want to practice data science, is pick the one that you're familiar with, because if you have domain understanding, it will help you come up with solutions, and not only come up with solutions, be able to explain solutions to end users, right? It's not done in vacuum. There's always to solve a given business problem, and that means if you already know the domain, that's one less thing that you don't have to understand or spend time studying. But it doesn't matter which domain you happen to use, so long as you have working knowledge, that's sufficient. You're not expected to be an expert in every domain. But that's reasonable thing. That's what separates data science from pure statistics or mathematics or computer science, the combination of those skills. Now, obviously, you can't learn all this in a very short period of time. It's throughout the course, but this expectation, this is the general expectation of a data scientist. Okay, that will take us, I don't know what time it is, to the Q&A session, and I covered most topics. If there are any aspects of the course or the discussion that we had not clear, or if you have any specific question, this is your opportunity to ask. So I will, I guess, unmute everyone, and let's see how it's going to work. And you can just go ahead and ask. Also, if you don't want to speak, you can type in the chat room, and I will be checking on that. There is a place to unmute everyone at the same time. Gotta give me. Or another option is for you to unmute yourself, and that's probably easier. That will prevent the background noise. So when you decide to ask a question, you can just right-click on your name and unmute yourself. And that's good. And then we have the chat window here, so that in case people are typing. Okay. Okay, I'm not sure. Okay, I guess this is a question from Nipol. I hope I'm pronouncing your name correctly. So you're saying, I am not the strongest in SQL. Is it going to affect my learning in R? No, no. SQL is a very useful data manipulation tool, so to be able to query data, to be able to make database changes. It's very important. I'm not trivializing the use of SQL. But for this course, and not only for this course, even beyond this course, it is one of those skills that if you know it, it's good. If not, typically on a data science project, you'll be working with data management folks that will provide you that data. But for this, in fact, we will not cover any SQL because we will provide the data that you will be using for the assignments and exercises. So you will not be querying any databases. So we will never be required for this course. Beyond this course, my background is I started as a software engineer, so I knew all these things before even I started data science. It makes life easier. You can speak the language with people that provide you the data management. But I would say you can get by without SQL for the most part. And it is not related in R. So the second part of your question is in learning in R. R is, you can use SQL in R, but there's no dependency on it. If you need to load your data from a database to R, then yes, you would have to write some basic SQL statements to fetch the data and load it to R. But there's no dependency between the two. From Paul, Python, R, and Java will be the most common use. SQL is in line to R. Yes, that is correct. Python and R are platforms languages. Python, in fact, is a more general language. You can use it for website design. You can use it for any other things. R, yes, you can do those things with R, but ideal for data science. Java is also a general purpose language, which is a compiled language, different from Python, and R are interpreted language. I don't want to get into what compiled and interpreted language is, but Java is a compiled language. It's faster. Okay, any other question? I wonder if Professor Gates is in the class. I didn't check her presence earlier. I guess not. So if you don't have any questions, I'll wait another minute, but in the meantime, I hope I have recorded this session, and will provide the link to replay. It's unlikely that everybody was able to attend, so at least you get a chance to see, to the extent you want to see the course material.
Yes, I have a question. If you can hear me.
Yes, I can. This is who? The George?
This is Dennis.
All right, Dennis, go ahead. Yes, I can hear you clearly.
Just a couple of questions, Professor. One is the chapters. There's a lot of reading we've been assigned, but only select chapters. Will we actually be provided the entire books at any point, or only just selected chapters of the selected books?
Okay, so that's one question. So when you say will we provide the entire chapter, the books are free. You can download all the chapters at the same time. If you go to the book's website, you can download all the chapters. The reason why providing one chapter at a time is because that's what is relevant for that particular topic that we're covering in the module. But if you're asking whether you can have access to the entire book, yes, the authors made it free for everybody.
Okay, thank you. One last question. How many more of these online presentations will there be? Will there be one at the beginning of each 2-week module?
So usually the lecture videos that come from me, I make them. In the past, I made them live videos like this, but people don't attend it, so I usually record it and post it. And so I just did for the entire course for each module last semester. Maybe I will change some of them, but that's fairly new, so unlikely I'm going to change all of them. Maybe I'll change add new ones to neural networks. So that is the lecture videos, but there will be for each module, the TAs will cover the R portion, which means like what packages you need, how you run a specific function relevant to that topic that we cover in the module. So those kind of webinars are provided for each module going forward. And then in fact, there is one right now this week, sometime this week. If it's not posted, I will post it.
Okay, thank you.
No problem. Okay, that's fine. If you don't have any question, then I will wrap this up. And like I said, we'll make the replay available, and you get another chance to look at it if you want to, at least for those who are not able to attend. And other than that, I will see you in class, and be looking forward for interactive session. Good night, everybody, and thank you.